Okay, good day everyone. We are from Group 3 and I'm going to present our project of hydraulic lab, the mini project. And our mini project is about the hydrostatic force on the plane surface. And we will not discuss the procedure, this kind of thing in not procedure. We are not going to discuss very detail about this thing because we have discussed in detail during the proposal. So in today's presentation, we are going to talk about the procedure of our experiment and also the result and our discussion. So now I'm going to give this presentation to Lohan.
Hello everyone, I'm Luhan here. Follow me, look at this picture. And PI means pressure and HI means difference of water level in manometer to the manometer zero level, where I1 to 7. And Y1 is head of the upstairs, and Y2 means head of the downstairs, and the Y gate is has difference between the lower part of the sluice gate and the bottom part of the flume. And we know the B is 31 cm west of the gate, and Y means the Y1 Y gate. Okay. From the experiment, this charge Q equals 785.3001 per minute. Y1 equals 24.1 centimeters. Y2 equals 1 centimeters. Y gate equals 1.6 centimeters. And then H1 point equals 3.2 centimeters. H2 equals 7.9 centimeters, and H3 equals 12.7 centimeters. H4 equals 15.5 centimeters. H5 equals 16.5 centimeters, and H6 equals 18.8 centimeters, and H7 equals 18.5 centimeters.
Okay, my name is Adirasana. So I'm going to show the video about our project. And okay, so the video show that we are calculate about the Y1. Y1 means the distance at the upstream, and this at the downstream. We call this Y gate, Y2. Okay. So okay, so the video show about we are calculate about Y gate. Y gate is the distance between the 0 manometer to the bottom of our sluice gate. So the video show we read the reading at the manometer at our sluice gate. So this our discharge. take the reading of this jet from here. Okay, that's all for our video for our project. So next, I will show the calculation that we use in our project, which we use the formula is F gate equal to 1/2 rho G1 square, and we are substitute. We already get our reading about our reading, and so we just plug in into our calculation our formula. So we use the density is 100 kg per meter cube, and the gravity is
1000 kg.
1000 kg per meter cube, and the gravity is 9.1 meter per second square. So we get the F gate is 74.673 kilonewton. This is our theoretical calculation. Okay, so next I will pass to the next person.
Okay, now we will use experimental approach. So first we will find pressure at 1, 2, 3, 4, 5, 6, 7 by using formula rho GH. Right. Okay. Then we can find Y by 4. So Y we get 0.225 meter. So now that we have find the pressure, now we can plot the pressure diagram. On the x-axis is pressure, on the y-axis is head. So by using this pressure diagram, we can find pressure at a certain head. So for example, at 0.1 meter, we can see that the pressure is 1,200 kilopascal. Okay, so now we will by find the area under the pressure graph, we can find the F over B. Okay, so then we find the area under the graph by using trapezium rule. So we calculate, and we can get 235.6078Y. Then we can find F gate by times B 0.3Y. So we can get the value of F gate 73.0138 kilonewton.
Okay, and so just now, previously they are explaining the result, how we getting our results throughout the experiment. And for the video just now, it shows like the procedure, how we're going to the procedure that we conduct this experiment. And actually, our experiment is not that difficult. It's just we make a sluice gate and let the water flow, and because of the hydraulic jump, I think they will be upstream and downstream, and we get the result. And of course, the water there's hydrostatic force. The water, there's pressure acting on the sluice gate, and we are getting this pressure, this force based on the height at the manometer, which means we are using the manometer to get the result, the pressure result, and alongside of the sluice gate. So for the result just now, from the formula method, we only use two parameters, which is the Y1, the upstream, and the Y2, the downstream. Just substitute the value and we get F gap, which is 74.673 kilonewton. And of course, in the pressure diagram method, yeah, we need to plot the pressure graph, which pressure graph. Sure. This pressure graph. And yeah, and we can get this pressure diagram, pressure graph, the pressure with the help of the manometer, of course, to get the pressure. So then after we get the pressure graph, we are going to calculate the area under the graph, which is we are using the trapezium rule to, you know, the trapezium rule. You imagine this is a straight line, this is a straight line. Then we can use the trapezium rules to calculate the area, this kind of thing. Yeah. And yeah, then finally the gap, the force acting on the gap is 73.013x. And when you look at these two ways, two approaches to calculate the force, you can see that the value will be different, but happily and luckily the value is just slightly different. Yeah, the value has not much difference, it's just a slightly difference. Which means this slightly difference might be caused by error. Some error that is happening during the experiment. So we can conclude that this experiment is a success. But we are still discussing the error. Why this value has still difference. The errors might be encountered during the experiment is hyraulic error, which means the one just now you see the Aini and Han Yu and Jing Yi, they take the reading. Maybe their eyes is not at the meniscus of the ruler, the value. So this is a human error that we cannot prevent. And also there's a leakage. The leakage that I'm telling here is that the leakage at the side of the sluice gate, because this sluice gate is not completely fit the fluid. That's why there's a weakness of this sluice gate is that when we look at the video, at the right side of the sluice gate, there is a leakage there. The water is flowing through, but it's just a small amount. That's why it won't affect much during the experiment. And also, there's a leakage when the water from the sluice gate flow to the manometer. We are using a tube to connect the water at the, like, imagine this is a sluice gate. We connect the tube at the sluice gate to the manometer. And because of this, the hole at the sluice gate, this hole at the sluice gate, of course we use the silicone to like gum adhere to prevent further water to leak. But we cannot prevent, this is the physics, the water still flow out from the side of the tube, somehow it flow. So I think this leakage will affect a little bit of our experiment results. So this is the reason why we got a slightly different of our result. So that's all. Then we can say that our result is experiment success, and that's all about our experiment. So thank you so much.